Okay, so let's have a look at an example of using Euler's method to get an approximate solution to differential equation. So in this example, we're given our differential equation. We're given a point on the original curve. We want to use a step size of 0.5 to approximate y when x is -1. So as a reminder of what we're doing with Euler's method, so we're given a derivative function. We don't know the original function, but we want to estimate it. So our original curve is unknown, but we know the derivative, so at any point we can calculate a tangent. We're always given one point on the curve. Let's call it x0, y0. So we can use the tangent to calculate a nearby point, x1, y1. That point, the distance away, is called our step size h, and we're calculating that using our derivative function. We can then repeat the process, a second time with a new tangent using our derivative function, again step size of h, to get another nearby point, which we'll call x2, y2. And we could keep on repeating that process. So in this example, our step size is 0.5. We're starting at x equals -2, and we want to get to x equals -1. So using steps of 0.5, we're going to need to do 2 steps to get to x is equal to -1, and we're trying to estimate that y value. So there's a formula for this, and in our VCE Specialist Maths, we have this formula on our formula sheet. Keep in mind here, our derivative is a function of x and y. Now on the formula sheet, it's just got f of xn, but we can use f as a function of x and y. It's no different. We're just plugging in an x value and a y value there. Okay, and each time, as we said, the x value is just increasing by a step size of h. Okay, so this is our derivative function, our initial x value and y value. So we can put that all in to our Euler's method formula to get an estimate for y1. So putting in x0, y0, and h, we can find that y1 is approximately -0.8. We then repeat the process with y1, x1, which we said was -1.5 because it's one step across and our step size is 0.5, and h, of course, still 0.5. So we repeat the process to get an estimate for y2, and that's the answer to the question. So rather than doing the calculation step by step like this, there is also a function on the TI Inspire for this, which is the Euler function. Now, it's not under any of the menus, but we can just type in Euler, E-U-L-E-R. Okay, but we need to put quite a lot of information into this Euler function. So the first thing we need to put in is our derivative, which we call f of x or f of x and y. That's always given in the question. Then comma x, comma y. Okay, could be comma t, comma x if we had a dx dt equation. In the curly brackets here, we've got x0 and the last value of x that we're interested in. So in this case, we were trying to find y when x was -1. So curly brackets, whatever your x0 value is, and whichever x value that you're interested in finding. After that is y0, and finally the step size h. Okay, so there's a lot of things to put into the CAS calculator there. Just keep in mind that f of xy here is the derivative function because the original function is unknown. So it is quite handy to have this, because once we type everything in, the calculator will just generate a little matrix with all the x and y values that we need. But I would recommend that you write something like this down in your notes, in your bound reference, so that you can refer to it and have a worked example there to help you.